Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to use the quadratic formula. The instructions for the example that we're going to be solving are as follows. We are to describe the nature of the roots of the given quadratic equation We're going to describe the nature of the roots of the given quadratic equation using the discriminant. Okay? Using the discriminant. And then we are to solve the equation using the quadratic formula. Okay? Then solve or find the roots. The roots are the solution to the quadratic equation, okay? Then find the roots, or think about it as a solution, using the quadratic formula, okay? Alright, so the example that we're going to be looking at today is the quadratic equation 3x squared plus 7 equals negative 2x. Okay, so the first thing we're going to do is we're going to use the discriminant to describe the nature of the roots. But before we start, let's do a real quick review on what the discriminant's rule is in determining the nature of the roots. Okay, so recall, your discriminant is a component of the quadratic formula. To be specific, it is the radicand. Okay, so your discriminant is b squared minus 4ac, and it's normally represented with the triangle symbol. Okay, so if your discriminant delta is negative, then that means that you're going to have two distinct imaginary roots. Okay? When we're talking about imaginary roots, we're going to have that I component there. Now, if your discriminant is 0, then you're going to have one real root. Okay? And that is also known as a double root. If your discriminant is positive, you're going to have two distinct roots, okay? They can be further separated into rational or irrational. That depends on if the discriminant is a perfect square or not. Okay? So let's say that the discriminant is positive and a perfect square. If it's a perfect square, what's going to happen is that the square root component will become an integer. So you're going to have a rational result. So in this case, you're going to have two distinct real roots that are rational. Two distinct real rational roots. Okay? Now, what if you have a scenario where your discriminant is not a perfect square? So if your discriminant is positive and not a perfect square, in that case, you're going to have two distinct real irrational roots. Okay? Think about irrational numbers as numbers that you cannot represent as the quotient of two integers. For example, you have square root, something like this. Root 2 is irrational because it cannot be represented by the quotient of two integers. All right, but any number that can be represented as a fraction of two integers is a rational number. All right, so let's keep these four cases in mind, and let's take a look at the quadratic equation that we're dealing with. Now, first thing we want to do in order to find the discriminant and use it to determine the nature of the roots is we need to write down the discriminant equation. Okay, so part one is to find the discriminant. Discriminant. All right, so our discriminant delta is b squared minus 4ac. Now we need to find a, b, and c. Now, one mistake that students make is they fail to put the equation in standard form before finding a, b, and c. Okay, so let's give ourselves a nice little caution here. Place equation in standard form first. Okay, what is the standard form? Standard form is ax squared plus bx plus c equals 0. You're basically setting the equation equal to 0 with the terms in descending order of degrees. Okay, so this must be done first before you determine what a, b, and c are when computing the discriminant and also the solution of the quadratic equation using the quadratic formula. All right, so let's go ahead and carry out our manipulation. 3x squared plus 7 equals negative 2x is clearly not in the standard form because, as you can see, it's not equal to 0. To transform it into the standard form, we simply add 2x to both sides, so it will be equal to 0, and then rearrange the terms accordingly. Okay, so we have 3x squared plus 2x plus 7 equals 0. So this, ladies and gentlemen, is the standard form that we're talking about. Okay, the beauty of the standard form is that it enables us to determine what a, b, and c are. So you have, this is your a, the coefficient of the x squared, b is the coefficient of x, and c is your constant. So let's go ahead and write that out. We have a equals 3, b equals 2, and c equals 7. Now let's find the discriminant. So let's rewrite the formula. The discriminant is b squared minus 4ac. The radical component of the quadratic formula, the radicand. All right, if we carry out our substitution, you have 2 squared minus 4 times 3 times 7. Now, one good practice when finding the discriminant or using the quadratic equation is to use parentheses. Now, the use of parentheses is extremely important when any of these terms are negative. Okay, you don't really see the benefit here because they're all positive, but whenever you have a negative term, you must use parentheses in order to avoid making sign errors or confusing yourself in the setup of the expression. Alright, so let's go ahead and simplify this using the order of operations. We square that, we get 4 minus 4 times 3 is 21. 21 times 7. Real quick correction, 4 times 3 is not 21. That's 3 times 7. 4 times 3 is 12. 12 times 7. Okay? Alright, so we have 4 minus 12 times 7 is 84. 84 minus 4 minus 84 is negative 80. Okay? So your discriminant is negative 80. So what does this tell us about the nature of the roots? Well, since we have a negative discriminant, let's go back to our notes. we said that if we have a negative discriminant, then you have two distinct imaginary roots. Okay, so let's go ahead and write that down. Since the discriminant is negative, we have two distinct imaginary roots, right, as the solution to the quadratic equation. Okay, so that's what we should expect to get when we find the actual roots. Now let's go ahead and complete the problem by actually finding the roots using the quadratic formula. Okay, so let's do that. Part 2 is to find the roots using the quadratic formula. Okay. Find the roots. Okay, now when you have a quadratic equation, let's say 3x squared plus 2x plus 7, as we have in this case, there are different ways that you can solve it. Okay, in this particular case, we were told to use the quadratic formula. Now, there are other methods that can be used. You can use the factoring method, you could use completing the square, or you can use a graphing method if you're equipped with a graphing calculator or some kind of graphing software. Now, the limitation of the factoring method is if you have a prime quadratic equation that's not factorable, then you're stuck. Okay? But the nice thing about the quadratic formula is that it always works. Whatever quadratic equation you throw its way, you will always be able to find the roots of that quadratic. Okay? The limitation of the completing the square algorithm is that it's long and involved. There are a lot of steps involved there. But the quadratic formula is actually the condensed version of the completing the square algorithm. So if you know how to use the quadratic formula, you are in good shape. Okay? So let's go ahead and write down what the quadratic formula is. So it's x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now, do you see the discriminant here? This is the discriminant. It is the radicand of the quadratic formula. Okay? So that's where it comes from. All right, so we already know what A, B, and C are, so let's go ahead and solve it. Now, the nice thing about finding the discriminant is that we already know what goes underneath the square root. Okay, so if we do negative b, let me put a, b, and c back here. So a is 3, b is 2, c is 7. So x is negative b, negative 2 plus or minus the square root of b squared minus 4ac. So b squared minus 4ac is negative 80. We already know what that is, so we can just put it here. We don't have to do the work again. And the whole thing divided by 2a. A is 3, so we have 2 times 3. Okay. Now this becomes negative 2 plus or minus root negative 80 over 6. Now let's go ahead and see if we can simplify this radicand. Okay, so we have root 80, root negative 80 actually. Now anytime you have a negative as a radicand, a negative number, that minus comes out as an I. Remember, the square root of negative 1 is I. Now we'll proceed to decompose 80 into product of primes, and then whichever factor repeats we will extract as a root, okay? So let's factor this out. We can take out 2 from 80. 2 goes into 80 40 times. Take out another 2. 2 goes into 40 20 times. Take out another 2. 2 goes into 20 10 times. Take out another 2. 2 goes into 10 5 times. Okay? Now, any factor that repeats itself, we can take the square root of the product of those two factors and just end up with one of them. So let us see what repeats. We have 2 times 2. What is the square root of 2 times 2, or the square root of 4? The square root of 2 times 2 is just 2. So those two can come out as 2. And then we have another repeated product of factors here. What is the square root of 2 times 2, or the square root of 4 is also 2. Now take a look at 5. It's there by itself. So 5 cannot come out of the radical because it's by itself, okay? So the final product is going to be the square root of 2 times 2. Now we'll have 2 times 2 root 5. Okay, let's go ahead and write that down. Alright, so we have 2. These two 2's come out as a 2 times these two 2's come out as another 2. The negative, remember, it comes out as an I. And the rad 5 stays behind. Okay, if we multiply these two 2's on the outside, we have 4i root 5. That's the reduced form of negative 80. Okay, so we're going to take this and plug it in this position right here. Alright, so let's go ahead and simplify further. We have x equals negative 2 plus or minus 4i root 5, the entire expression divided by 2a. Now, one thing you want to be careful with is you have to divide the entire numerator by 2a, not just the radical part. Okay? Now, let's go ahead and reduce. When we're reducing, we will look at all three integers. Okay? So we're looking at negative 2, we're looking at 4, and 6. And then we're going to ask ourselves, is there a number that goes into all three? Is there a greatest common factor that we can divide all three by? Okay, it's as though it's all or nothing. If we don't have something that goes into all three, then we're done. So what is the greatest common factor of 2, 4, and 6? The GCF is 2. So that means that this expression can be simplified. To achieve that, we'll simply divide every single integer by the GCF, which is 2. So divide 2 by 2, divide 4 by 2, and divide 6 by 2. Okay, that will give us the simplified form of our result. So we're going to have negative 1 plus or minus 2i. 4 divided by 2 is 2 root 5 all over 6 divided by 3. 6 divided by 2 is 3. Okay? So let's separate our two answers so you can see the two roots that we have. The first imaginary root we have is negative 1 minus 2i root 5 divided by 3. That's the first root. The second root that we have is negative 1 plus 2i root 5 divided by 3. So we're just splitting this answer using these two signs as our basis for separation. Okay? So these are our two imaginary roots, and we see why they are imaginary because we have that I component in the result. Okay? So this is basically how you use the quadratic formula to find the roots of a quadratic equation. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your study of quadratics, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comment section below and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day. Goodbye.